And we're back. Okay. Now we're talking about the actual bonds and ionic compounds for section 7.2. And let's get right into it. So, an ionic bond, okay, a compound composed of ions, okay, a cation, and an anion is an ionic compound. Okay, in fact, you're going to see a question coming up here soon that says, what things are found in an ionic compound, or a cation and an cation and an anion make what kind of compound? And the hint is there's an ion at the end of that word, and there's an ion at the end of that word, and so they would make an ionic compound. So, an example is the formation of sodium chloride. Sodium is 1s2, 2s2, 2p6, 3s1. Or in other words, you've got a nucleus with a single electron around it. This is the 3s1 electron on it. Now chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. And because sodium has a 3s1 and chlorine has a 3s2, 3p5, those are its valence electrons. This 3s2, 3p5 is going to have a chlorine nucleus and a valence shell of 1, 2 for the S's, and 1, 2, 3, 4, 5. And so chlorine is going to have 7 electrons around it. When the ionic bond forms, this 3s1 electron goes and hooks up right there to chlorine, leaving sodium with the 1s2, 2s2, 2p6, and chlorine with the 1s2, 2s2, 2p6, 3s2, 3p6. And lo and behold, this one now kind of looks like neon, and this one kind of looks like argon. And they're both happy, but they both have a charge. The sodium now has a plus charge, the chlorine has a minus charge, and as we know about charges, opposites attract. And so it's this positive negative charge is what attracts them to each other and what keeps them together. So even though they're composed of ions, these ionic compounds have a net neutral charge that our total amount of positives equal our total amount of our negatives. The force that holds ions together in ionic compounds is the same force that holds electrons around a neutral atom and causes our ionization energy trends and all of that stuff. The force is called electrostatic attraction. The electrostatic attraction between the positive charge of the sodium and the negative charge of the chlorine is what causes these ions to attract together. Okay? We call one of these things a formula unit. It is 1 unit of an ionic compound, and it is the lowest whole number ratio of ions in a compound. Now, our chemical formulas are going to show the kind and the number of atoms in a compound using the element symbols and the subscripts to show the numbers of atoms of each element in the compound. Okay, so sodium chloride here is going to look like, okay, the formula for it would be this, NaCl, which is going to have 1 sodium atom and 1 chlorine atom. Now over here we have H2SO4, which this would be called, by the way, sulfuric acid. Okay, and our sulfuric acid is going to have 2 hydrogen atoms. It's going to have 1 sulfur atom, and it's going to have 4 oxygen atoms. You can tell that from the 2 here. Nothing here. It's kind of like if we have well, if you're counting, if you have x in algebra, you use x. You don't say 1x all the time. You just say x to mean that 1. It wouldn't be there if you didn't have it. Down here, magnesium. Does magnesium, how many magnesium atoms do we have? We have 3 magnesiums. Let's scroll down a little bit so you can see that. I'm not sure you can see that yet. Okay, I think you can see it now. Our magnesium here. We have 3 magnesiums down there, so that magnesium 3 means 3 magnesium atoms. Now, this PO4 parentheses 2 means that there's 2 of everything inside, which means that there would be 2 phosphorus atoms. And how many oxygens? Well, if there's 2 PO4s in there, that's going to be 8 oxygen atoms. And the name of this one is actually magnesium of phosphate. No, that's ugly. Let's try that again. Okay, so instead of the writing, I just decided to, give it the letters. That's going to be magnesium phosphate. That's the magnesium. That right there would be a phosphate. Okay. The next one is going to be magnesium acetate. Magnesium acetate. Oh shoot, it didn't give it to me. And the magnesium acetate is going to have what? It's going to have 1 magnesium atom. It's going to have 4 carbon atoms. It's going to have 6 hydrogens, and it's going to have 4 oxygen atoms. Okay, and all that is in that one compound right there because we have 2 of everything inside. Okay, and so those are all the atoms that are in ionic compounds, and we'll show you how to make more of those in a bit. Now, we have properties of our ionic compounds. They are mostly crystalline solids at room temperature. They usually have high melting and boiling points. They are usually hard and brittle. And ionic compounds conduct electricity when they are melted or dissolved in water. Okay, and so you're asked to go look at figure 7.11, but of course I am too kind for you guys, and so I will show you figure 7.11. And lo and behold, this is molten salt. Now it's really hot. Okay, however, when it's this hot, that means that the ions are free to float around. And if we hook it up to a power source, like say, a car battery, the flow of electrons is going to go one direction. And what that causes is positive ions to be attracted to the negative. And if positive ions are attracted to the negative over here, this is going to cause negative ions to swing over here to the positive charge. Okay? And there's actually going to be a flow of charge moving around, which is going to allow electrons to come back through the current meter. You can tell that there's a current, and it's going to come back to the power source. Okay, and this is pretty much how batteries work in a different kind of way. That we are actually able to store electrons on one side of one of these things, and when we hook them up to a source, the electrons are allowed to flow back to the other side, and that's really why you hear battery acid in your batteries. It's because it's an ionic compound that is allowing the flow of electrons in this similar sort of a situation. So, the last characteristic is that they generally occur between metals and nonmetals. They occasionally occur between nonmetals only, but that is when the nonmetals are creating a cation in a special configuration. So, we're going to take a quiz here, and we'll finish up 7.2. So our first question is right now. Okay, first question, which chemical formula is incorrect? Now, this is going to be a little tricky here. Remember, our ions are always neutral, and so we need to identify what the charges are on each of our ions. Cations come first, anions come second. Cation, anion. Cation, anion. Cation, anion. So what are the charges on these guys? We've got a potassium, has a K+. We know the fluorine is over there, halogen, it's got a minus. Okay, calcium over here is a Ca2+. Magnesium is a 2+. And sodium is a +1. Now, if you need help with these, remember from 7.1 that the ions are formed by either cations are formed by losing electrons to make them look like a noble gas. Now these guys on the other side, sulfur is 2 spots away from looking like argon, so it's going to gain 2 electrons. Oxygen's 2 spots away from looking like neon, so it's also going to gain 2 electrons. Okay, and bromine is a halogen, so it's going to gain 1 electron. Which one of these then is incorrect? Which one of them has more of one charge than another? Because this Kf2 means that there's 2 fluorines over here. Well, calcium has a +2 charge and sulfur has a 2- charge, so those 2 balance. Magnesium has a +2 and oxygen has a -2, so those 2 balance. Sodium has a +1 and bromine has a -1, those 2 balance. So all of those are actually correct formulas, leaving us with the potassium fluoride, which is an incorrect formula. So that's how you do that one. Let's take a look at the next one. And there we go. Ionic compounds can conduct an electric current when? Only when melted or dissolved in water, only when dissolved in water, or when they are solid or melted. Well, if you look back in your notes, you know that the correct answer is B, when they are melted or dissolved in water. Okay, and then finally, our last quiz. At room temperature, most ionic compounds are what? Are they crystalline solids? Are they liquids, gases, or soft, low melting point solids? Again, if you look back in your notes, you'll find that the answer is A, crystalline solids. Okay, so that's it for section 2. If you have any questions, or we'll move on to 7.3 next. If you have any questions, go ask me when you come into class, and we'll talk to you guys next time.